Switch number 4, please. So this is switch number 4. It was a success on switch number 3, which was amazing. I did not expect that. This one was in a little separate bag and it said water damaged on. You can see on the screen the residue of the water. So that's definitely probably not going to work. It also looks damaged, but we'll see what happens. We are drawing a 15 volts, 62, 68 milliamps, 22. Oh, fan's just kicked in. Oh, fan's cut off. It's turned off. It's starting back on, off. So that's showing that it's Wait, what is it doing? That fan's kicking up. Is it another issue with the fan again? Hang on, hang on. I think it is. What's this one? This one don't even detect. Ah, the fan is going. You guys can't hear it, but all these got the fan issue. That's crazy. All right, let's have a look. It says it's water damaged anyway. Fan's still spinning. It's not even turned on. Let's see what's in store. It is very furry inside. Very furry. Very furry. Even on this side, which is annoying because it means I'm gonna have to sort that out. Oosh. Let's go under the microscope. Right. So yeah. Lots of fur. Look at all that on there. That's like real fur. This side, again, there's damage. Damage. Hopefully that hasn't affected the backlight. Oh, the fan's just kicked in again on its own. Now it's stopped again. But there is corrosion on the fan there, so that could be the issue. It just needs another general cleanup. Hopefully it will sort it out. So I'll be back once it's all stripped down. Are we ready to see the damage overall? I've not looked on the other side yet. So we saw the damage here, there, there, over there, over here. So a lot of damage everywhere, but it's not extreme. Ready for the other side? Mm. Okay, it's not too bad. It might be repairable. Okay, let's just get scrubbing and see what happens from there onwards. It's all cleaned up now. Let's check what we get. I think I'm going to buy a new ammeter, not this type of one, but a better one. 15 volts, 0 amps. Yeah, I think the port's dodgy on this one as well. Come on. There you go, 15 volts, 0 amps. Okay. Now, I might have to clean up the display ribbon cable on this one. Yeah, no, actually, the display ribbon cable's fine. But what about the backlight cable? Now, last time I'd done this, okay, that's good as well. Good. Last time I'd done this, I ruined the display, but the display's ruined anyway. So I'm not going to spray directly onto there. I'm just going to spray it on the toothbrush. Also get this cable out. No fan spin yet, but could just be because it's flat. Right. Do we get a reading? A stable one, please. Nah, see? The fan instantly kicks in as soon as there's power to it. Let's check. That's probably going to turn off in a minute. Let me prop this up so it stays reading. No, you're not gonna. There. Leave it like that. Nope, it cut off again. Let's measure the voltages while it keeps cutting on and off. There you go. Constant 4.9 that side. There you go, 4.8. Do you see that then? It boosted up to 4.8. So it's that chip again. But I don't know if it's powering up. That's why it's cutting out. No, it won't be powering up. The battery's too flat. And the port. Why is the port dodgy? Let's have a look at the port. I don't know. The port seems okay, but it's interfering with my testing. So what I might have to do is just quickly replace the port, and then I can fully test it again. Okay, so I am going to reflow that chip first. Plugging it in, put in that back in. Now let's try it. Nothing. Oh, okay. I can't get a solid reading on that side. Let's try this one. Right, that looks normal now, look. 16, 160 milliamps. That's normal charging, like dead battery charging. Yeah. There's no display, obviously, because I think the display's broken. What I'm going to do is try and leave it. The battery's not even spinning anymore. The fan. I'm just going to try and leave it like this and see if we get a higher amp draw in a few minutes. Be right back. It's been on charge now for 5 minutes and it's still not moved. So obviously that hasn't fixed the issue. Well, it's fixed one of the shorts. Um, okay, what's the next step? Thermal cam, maybe? See if the battery even has any charge. It should have zero if it wasn't charging. So if it's got more than zero, then it's definitely doing something. 3.3 volts. Yeah, let's check for shorts first and see what we're getting. All right. All right, let's change the port out. Oh, damn it. I wasn't recording the whole time again. Oh man, this sucks. Anyway, so what I did, I put the thermal cam on and it showed up the inductor underneath that chip I reflowed for the fan, and that got hot. So did the cap above BQ. So I took the cap off first above BQ and the short's still there. So now I've taken off the inductor, which I don't think it's the inductor anyway that's causing the short because it's only just a coil anyway. So it is most likely this fan chip that's failed. But I wonder if it starts up without it. But anyway, let me check for the short, see if it's gone. If it hasn't, I'll put both back and then take off the other chip. So, oh, find that side. So it's this side should be short. It is, okay. So one side is not short now. Look at that. 196 ohms, which I think's fine. So it is that other little chip. Let me take that chip off then. And then if it is, then I'll put the other two on. Yep, the short's gone. Mega ohms, kilo ohms. So that short has now gone. So it was that chip. Okay, so hopefully once I've done that, it should come to life. And now I've got to reball another one, put these other two chips back on, capacitor and inductor, and we should be good. But let me carry on, let me do that quick. I mean, I don't know at this point. I don't know if it is sorted or not. It says zero. Let's just plug in the battery, see if we at least get a normal charge. But this is it for now. I'll work on it again tomorrow. I'm live streaming later today anyway, so we're gonna get a normal charge. Ooh, we are 52 unless that's another short. 55, 57, 51. I don't know at this point. Okay, that is different. It is higher though, so there might even be a short under that chip that I just done. But let's plug in the LCD and the backlight. You never know. All right, let's have a look. Let's turn that off so I can see the backlight. Ready? Nah, I don't know if that is normal or not. I don't see a backlight. Hello, so it's the next day, and my live stream last night. It went really well, and it was fun, and yeah, great. You should go watch the live stream back. This is the switch that I was doing in this video, and it had a very large heat spot on the APU. Can't think what else it could be, so I thought, you know what, I'm just gonna do an APU swap. So I've hand reballed the NAND, and I reballed the APU. Another one, by the way. So I'm going to see if this fixes it. There was a torn pad, and I'll show you it was a major pad as well, but it's not connected through the wires, through the traces. It was just connected through the wires. So if I go to the microscope, look, you could see this is one that there was a wire underneath it, so I had to repair it. Hopefully that works. It's worked before. So yeah, let's hopefully see if this works. I'm going to do the APU first, actually. I think this APU's popcorned. Oh, for God's sake. Hopefully that won't affect it. We'll see. Most probably will. That is gutting. That is gutting. But why? Oh well. Try do the NAND. Wow. There we go. It's worth a go, innit? It's either gonna work or it's not. Alright, what are we getting? 48, which seems normal. Let's have a laugh and plug it in properly. Just at least the backlight. Let's see what happens. Oh, and the display. You never know. It might show something up. I'm not reballing another APU. This one's just gonna have to be in the donor pile. Oh, there we go. 52. It doesn't look good. Solid 52. No display. The screen could be damaged anyway. 55. Nah, that APU's getting hot again where that heat spot was last time. I'm gonna have to give up on this one. Game over.